Introduction: the star that sustains us. The Sun is a middle-aged G-type star at the center of our solar system. It is not static. It is a dynamically active ball of plasma, constantly churning with magnetic fields and seething with energetic activity. Its influence reaches every planet, moon, and object in the solar system. But sometimes the Sun releases bursts of energy so powerful that they ripple across space. These are solar flares, coronal mass ejections, CMEs, and solar storms, and they can affect the entire system. Volcano: what are solar flares and CMEs? Solar flares. A solar flare is a sudden explosion of electromagnetic energy on the Sun's surface, the most powerful explosions in the solar system. They release intense radiation across the spectrum, including X-rays, ultraviolet, and radio waves. Flares are categorized by strength: A, B, C, M, and X classes, with X class being the most energetic. The energy released can equal millions of hydrogen bombs exploding simultaneously. Coronal mass ejections, CMEs. Often associated with flares, CMEs are colossal clouds of charged particles hurled into space. When a CME is Earth-directed, it can drive powerful interactions with planetary magnetic fields. Solar activity follows an annual 11-year cycle. At peak, solar maximum, flares and CMEs occur more frequently and intensely. How solar activity affects Earth. Earth's magnetic shield. Earth has a protective magnetic field, the magnetosphere, that deflects most charged solar particles. But when a strong solar storm hits, the magnetosphere can be disturbed, triggering geomagnetic storms. Auroras. One of the most beautiful effects. Charged particles spiral along magnetic field lines and collide with atmospheric gases, creating aurora borealis and australis, northern and southern lights. Disruption to technology. When energetic radiation reaches Earth, it can interfere with radio communications and radar, disrupt GPS and navigation systems, damage satellites or shorten their lifespans, cause power grid outages due to induced electrical currents. Strong geomagnetic storms have historically caused satellite malfunctions and power system failures. Atmospheric and ionospheric effects. Solar flares increase ionization in the upper atmosphere, ionosphere, which disturbs radio wave propagation and can cause blackouts of shortwave radio from minutes to hours. Planetary effects. Mars, the naked planet. Mars lacks a global magnetic field. This makes its atmosphere vulnerable to the direct impact of the solar wind and particle storms. Solar flares and CMEs can strongly ionize and heat the Martian upper atmosphere. Earth versus Mars example. In 2001, a solar flare hit both Earth and Mars nearly simultaneously, altering the ionospheres of both planets, a clear example of shared energetic effects across the solar system. Planets with strong magnetic fields. Planets like Jupiter have extremely powerful magnetic fields, much larger than Earth's, which can trap solar particles and produce intense radiation environments. Human and technological stakes. Astronaut safety. Astronauts in space, for example the International Space Station, are exposed to increased radiation during solar storms, requiring careful monitoring and mitigation. Modern infrastructure risks. Our modern world depends on satellites, GPS, aviation, and power grids. Scientists warn that a Carrington-class event, the strongest recorded solar storm, 1859, could cause catastrophic failures today if it struck Earth now. Conclusion: a star that shapes worlds. The Sun is not a passive ball of light. It is a dynamic star with the power to influence every planet in its system. Solar flares, CMEs, and storms are natural expressions of that energy, capable of creating breathtaking auroras on Earth and posing real challenges to our technology and space endeavors. Scientists continue to study the Sun using satellites and probes, improving predictions and warnings so that humanity can better adapt and prepare for these stellar tantrums. This would be followed by visual elements listed in the script.
At the center of our sky burns a star that never sleeps, a living ocean of fire and force, the sun, the star that sustains us.
A middle-aged star of golden light, a churning sphere of plasma and flame. Magnetic fields twist and collide, shaping every world in its domain.
Not silent, not still, but alive with endless motion. Its influence reaches far beyond Earth, across the oceans of space. When the sun awakens in fury, the heavens begin to shake. Solar flares ignite the darkness. Coronal storms escape.
A million bombs in a single breath, ripping through the void. From the heart of our star, the universe feels the noise.
Explosions of light and radiation, X-rays tearing through the sky. Voltage-charged cosmic fire, launched where the planets lie.
An 11-year rhythm of fire, a cycle of calm and rage. At solar maximum, the sun breaks free from its cage.
Earth stands shielded by magnetism, a fragile, invisible eye. And even shields can tremble when stellar tempests fall.
Auroras paint the polar night, green and crimson waves, particles dancing with the sky in nature's grand display.
But beauty hides a warning, signals bend and fade, satellites drift into silence, power grids feel the strain.
Astronauts watch the warnings rise, radiation floods the sky.
One Carrington level event, and the modern world could cry.
If the science soars in space, we learn, we watch, we prepare. Satellites listening to the sun, reading its silent glare.
A star that gives us life and light, and tests our fragile way. The sun, a force that shapes all worlds, both created